we are looking at vector, converting Cartesian into vector form is what we're doing. So what you want to do, Marie, is just set all of these equal to lambda. So you have y equal to lambda, 1/3 x plus 2 equal to lambda, and then you solve for x and y. So when I did that, I'm going to get y equal to 0 plus lambda, x, let's see, I'm going to do this in pieces here. 1/3 x equal to negative 2 plus lambda. So if I multiply by 3, I'm going to get x equal to negative 6 plus 3 lambda. Is that part okay? So I set it equal to lambda. Each one solve for x and y. Now you can kind of see the vector taking shape, can't you? So this is xy equals negative 6, 0 plus lambda times 3, 1. Ta-da! There it is. Anybody want to see B or C? Jacob, you want to see B? No? Good? All right. How about 8B? Do 8B. This is a vector intersection. Make sure that you can do these. We'll probably have a little quiz on this Friday-ish. So make sure you can do an intersection. Whenever you see R, what can you replace it with? X, Y. There you go. We're going to do that with both of these. And we will break them up into parametrics. So you get x equal to 0 plus 2 lambda. Y is equal to 4 plus 5 lambda. Then you're going to have x is equal to 2 plus mu. And y is equal to negative 2 plus mu. Okay. Jacob, what was the challenge that you had with the intersection? Oh, okay. So let's set the x equal to x. How does that sound? So you have 0 plus 2 lambda is equal to 2 plus mu. Or you could just say 2 lambda equals 2 plus mu. Then we'll do y equal y. And I have 4 plus 5 lambda equals negative 2 plus mu. So 5 lambda equals negative 6 plus mu. So this should be off. Really? There we go. All right, so then you just put these two together, and you'll have 2 lambda equals 2 plus mu. 5 lambda equals negative 6 plus mu. And you can solve for mu if you want, Jacob, but what I would do is I would just take the opposite of these and add them up. 0, negative 8, 2, this would be 5 lambda minus 2 lambda is 3 lambda. Lambda equals negative 8/3. Is that it? No, that's nothing. All that is what lambda is. You got to find out what the coordinate is. So you say lambda is equal to negative 8/3, then put it in right here. Lambda is negative 8/3. Negative 8/3. And so when I do that, I can calculate the point x equal to negative 16/3. Y is 4 minus 40/3. 4, by the way, is 12/3. So 12/3 minus 40/3 is negative 28/3. This coordinate negative 16 thirds, negative 28 thirds is your intersection point. And guess what? It's right. The answer, negative 16 thirds, negative 28 thirds. Pretty cool. Any other questions on number 8? Are you ready for 9? Okay. Won't do all of number 9, but I'm going to try to get you started on that. So with 9, how many were having a little trouble with 9? A little difficulty with it? Only 2? Okay. What, Sean, what was your main challenge with 2 or with 9? So let's talk speed and distance here. In part A, it says find the speed of the airplane. Whenever we want to find speed, we got to look at the direction vector because this is distance, this is distance, and this is distance. Distance equals distance plus distance, right? But this is a package deal. Time times something is equal to distance. So what is that? Velocity, sure. Otherwise, you're not going to be able to figure that out. So that yellow part I have here is going to be your velocity. So if you find the magnitude of the direction vector, the magnitude of that, you're going to get the speed. So the square root of 3 squared plus 4 squared plus 10 squared equals the speed. Is that part all right? Looks pretty good. And you can calculate that and check that out. It'll be the square root of 125, whatever that is. I want to say 11.0 something. Okay. At 1300 hours, the second model airplane is at a different point. After 2 minutes, it's at point 3:16:39. Show that its position vector is given by this. So this is where we started, and this is where we ended. In here. So there's the start. Well, notice the start is right here. Negative, thank you. Negative 5, 10, 23. So this is the start. This thing here. What's 438? It's the velocity. It's the direction vector. So if this was point A and this was point B, what would vector AB look like? Head minus tail. Negative 5 minus 3. Actually, we start, the head is here at the end. 3 minus negative 5, 16 minus 10, and 39 minus 23. Now, I get 8, 6, 16. But this says 438. What did I do wrong? It's 2 minutes. So if we factor out a 2, this is going to be 2 times 438. So does that match this thing? Perfectly. So there you have it. We showed that the position vector was, this is the point, this is the direction vector. All right, now you have 2 vectors up here, 2 of them. You show at what time the planes meet and what that intersection point is. I'm going to let you do that right now.